Yo, what is up? So today I'm going to show you guys how to implement k-nearest neighbor algorithm with code and not using like a library to create the kNN instance. We'll use like basically one library, which is NumPy, so we can do other vectorized calculation, and then we'll use these sklearn datasets to just like test our code. So I'll show you guys how it performed. It's actually quite nice. So let's see. I'll just briefly talk about the iris dataset, but yeah. So you will see I have a pretty good accuracy. It's like basically 97%. Um, yeah, it's quite good. And in the iris dataset, there's three classes that we want to predict. If you really want to get into it, you can just search it up on Google or something. But basically, 0, 1, 2 just represent the flower type. I mean, yeah. Um, basically that's it. Let's just get into the code. Oops, sorry. So import numpy as np. So numpy is one of a very important library that you need to learn when you're like a beginner sort of thing. But like when you get to more advanced um like a period of like machine learning, we'll tend to use tensors instead of numpy vectors. But that would be later. So let's just do this. Let's just import the iris, load iris, and then from sklearn dot module selection, import train test split. I mean, I might actually also do a video on train test split, but that will be next time. Iris load iris, and then the x will equal to iris data, which is the information that we know, and the y will equal to iris target. So I will just quickly show you guys what the data and the target look like. But like yeah. So it's pretty simple. We have basically 4 variables, right? I mean, not really variables, but basically these 4 things like data and then the class. But you see the class is organized here, which is like I guess quite nice. But another thing is that when you shuffle it, which is quite nice, since the train test split automatically just provide this function xtrain, xtest, ytrain, and ytest will equal to train test split x and y test size will equal to 0.2. Oh, also another thing that I forgot to talk about is that this time we will use a class for this kNN model, since usually I do use functions because it's so much more like simpler and I don't really like class, but it's quite convenient, so we're going to use class this time. And yeah, basically that's it. Let's just get into the code. And so class kNN, we don't really need to inherit anything. By the way, you guys can just try to learn a bit more about kNN and class. If you don't really know a lot about it, or just watch my previous videos. But the thing about this video is that I'm more going to focus on implementing the code instead of really like talking about that much about it. But it's alright. So this will also be a very basic kNN class model implementation. So first we'll define init, which basically you need to define it in all of the class that you create, I'm pretty sure. And then self, which is an attribute that you always need to have. And we don't really need to do anything when we're initializing the model. And then we'll do this, we'll call it fit. If you watched my previous videos before, then you will know that fit is one of the most important functions in sklearn models, since it will just take in the data, process it. But in this case, we don't really do that. Self.xtrain, which is equal to x, and self.ytrain, which is equal to y. So the reason why we don't need to do that is because kNN, it's more like, it's not really that of like a typical machine learning model. It's more like comparing. Like we'll compare all the data with the training data and then give out the data like label that it's the closest. And when you go to the more advanced stuff about kNN, you can maybe like choose by majority. Maybe you can give a weight by the distance, but we will not really do that since it will be a short, sweet video, just quite basic. And then now we'll go to the important part, which is predicting. And still we need self, obviously. And then we'll take only x because what we don't do is predict. So we don't really have the label. And what x it's not just one label. It might be like a whole vector. So like in this case, this x test, it's not really one data. It might be a vector of the data, which is also a vector. So that's maybe a bit harder, but it's alright. So first of all, we'll declare this num test equal to x.shape 0. So what this means is it's quite simple. So basically, we'll look at this x and we'll find its shape. Basically meaning all the like size and information about x. We'll take the zeros element, which will give us the rows of this data, which give us like how much data there are. So we can know the length of the vector basically. And we'll create something called ypred, which will equal to np.zeros, a pretty useful function. So basically it will create a vector full with zeros with the size of num test, since we have the data and want to give out a list of predictions, since we're going to give a label for each of the data. And then we need to ensure that the type of it is ytrain. Oops, self.ytr.dtype. Just making sure the type. If it's 0, numpy zeros is correct. And now let's use a for loop. So in a for loop, there will be a a bit more like advanced vectorized calculation, but I think I can explain it in depth, and I hope I will. So what we'll do is first we will iterate through everything. So for I in range of num test, which like the num test is just the length of the data. So we'll just loop through all these index. And then what we'll do is we'll find this thing called distance of each uh, each training sample and the sample that we want to predict. Since we want to like compare each data points and find the data points that's most similar with our prediction, like the thing that we want to predict. So first of all, so I will just basically write the code down first, and then like explain it. Also, by the way, I do recommend to really just learn a bit about these NumPy stuff, since it's quite important when you just start machine learning. And yeah, basically that's it. All right, so now we're basically done. Also, we don't really need this parenthesis. Sorry. All right, so now we're done, and I'm going to explain everything. So this xi and this is basically just getting the data, like each route of data. And self.xtrain is the training. So here we perform this vectorized calculation where we just subtract the data from the whole training sample, and we need to find the absolute value of this. Since we don't really want there to be like negative and positive, we want to view them as a thing same, since we're trying to find the distance. Also, by the way, this is trying to find the Manhattan distance. And so yeah, and then for the x equal np.sum and x equal to 1, it basically means that what we'll do is that we'll sum up all these differences between these two, like not really two vectors, but the training samples and its prediction. And x is equal to 1 is basically, we want the sum function to do that. And we will also, this will give us a result of a 1D array called distances, where each element represents the distance between the ith test sample and a particular training sample. So now oops. Sorry. So now we got all the distance of the ith test sample and a particular training sample. But just like what I said before, we want the smallest distance, since we want to give the label of the training sample that's closest to the testing sample. And it's quite easy to implement that. So mean index, that would just be equal to np.arg mean in the distance. So what this will give us is the minimum distance in this distance array, and it will find the index of that. Okay, so now what we will do is we'll change the web pred's ith element. It will equal to self.yTrain of this ith element. So basically, a quick summary: this line will find the distance of the data that we want to predict with all the training samples, and then we will find the index of, oh sorry, this is not I but mean index, and we will find the minimum distance, I mean like minimum number in this distance array, since we want to find the smallest distance between each sample. And what we'll do is just change the ith element of the ypred to the training sample, like the label of the training sample, which is min index. And then what we'll do is just return ypred, right? Quite simple. And because of the conveniency of NumPy, we can just make this, it should be pretty long, code into these 3 short and concise lines that will take up a whole lot more lines of code if we didn't have NumPy. And then now we can just basically create an instance called model and kNN. So it's just an instance of this class, and then model.fit xtrain and ytrain. Quite simple. So we can just use the model predict, model.predict, let's say xtrain, like let's just say xtest, and let's say the fourth one, and we'll just print this out. And we can see what it think. Wait, what? Okay, did I make the train test split thing wrong? Ytrain, ytest, print model.predict xtest. Oh wait, we can just let it predict the whole thing. Yeah. So it'll give us this array of the answers, like what I think is true. And then we can print like the answer, which is ytest. And you will see majority of them are correct. Actually, all of them are correct. Oh, beside this one. So the model think it's like type class 1, which is one type of the flower iris, but it's actually not that one. And if we want to calculate the score, we'll just write another function, and you can write as many functions in this class as you want. Maybe you can make it like become a real kNN, where you can specify how much neighbors you want to define to really characterize it by its labels. I would make that like a homework, I guess. But yeah, define score. This is also a function that I tend to I use it a lot, quite a lot, just to see the score, and it will give us x and y. And what we'll do is we'll just do this very interesting thing called use this prediction self.predict x, and then for I in range of so prediction will equal to self.predict x, since it will return an array, and then we'll just do this, get the index of all these prediction. I forgot a colon. If, and then we just compare it simply. Before that we need to set the correct. This is the correct amount, and at first it would be 0. So if prediction I equals to y I, so if it's equal to the answer, then correct will be like we just add 1 to it, and then we'll return not correct, but correct divided by the length of the prediction, since this will give us the accuracy, which will be from 0 to 100. And then this means we don't really need to write the prediction to test how well our model done. We just need to model.score x test and y test. I hope there will be not really any error. Oh my god. So okay. Oh, I see. So it's not. It should be the length of prediction. And this should be it. Yeah, it'll give us an accuracy of 97%, which is pretty good. And thanks for watching. Please subscribe.